All right, this should be fairly easy. We're in Geometry Lesson 13, which is Introduction to Triangles. Should be stuff that you're fairly familiar with, but just in the event that you're not, we should know that a triangle is a three-sided polygon, and in fact, it is the polygon with the fewest number of sides that we can possibly get. You can't get a polygon with fewer than three sides. It takes three sides to close it up. So that's why triangles are really important, not just in geometry or in math, but just all over the place. Triangles get used for a lot of different things because it's really the most basic shape that you can make. You can't really make anything more basic than a triangle. So we find that in other polygons, polygons are made up of triangles. A triangle can also be classified by its angles or by its sides. And we're going to show from our table here, both on this table and on the next table, how we can classify triangles. Okay. Here we see that we can classify triangles by their angles. In an acute triangle, it's a triangle that has three angles that are all less than 90 degrees. Okay, that makes sense. Okay, then we have an obtuse triangle. It only has to have one obtuse angle to make it an obtuse triangle, right? The other two angles are by definition, they have to be acute. And then finally we have a right triangle, which is a triangle with one right angle. The other two angles are going to be acute, right? Because there's only 180 degrees in any given triangle, okay? No matter how big or how small. Okay, let's see, and then we deal with different types of triangles. For one is what is called an equiangular triangle. That means all three angles of that triangle are congruent. They're all the same. Any equiangular triangle, all angles are going to be 60 degrees because 180 divided by 3 is 60. So all of them are going to be 60, okay? In an equiangular triangle, this doesn't say this up here, but an equiangular triangle will also be equilateral, meaning all sides will be the same length. Now, they can be any size, it could be any length, but all three sides are going to be the same. We can identify triangles by their side lengths, and so we'll look at the summary of that here. Equilateral triangles, we're going to show these by using tick marks so we can show which sides are congruent. In an equilateral triangle, all three sides are the same length. In an isosceles triangle, exactly two sides are the same length. And in a scalene triangle, none of the sides are the same length. Okay, they're all three different. Okay? All right. And so you can have an isosceles right triangle. You can have an acute isosceles. You know, we can come up with different combinations of things. Typically speaking, though, I mean, you could probably have an isosceles obtuse. Okay. I don't know about having a scalene acute or anything like that. It really probably there are some situations, but as basic as this may seem, you're still going to be asked both on tests and in your homework to be able to classify triangles, and you need to know the difference between which ones deal with angles and which ones deal with sides. Okay? Yeah. A right triangle is being classified by its angle. What are you asking? It could be a right triangle can be isosceles, but it's not always isosceles. Okay. I mean, an isosceles triangle can be scalene, all three sides being different lengths. For instance, a 3, 4, 5 right triangle is scalene. It can be isosceles. The only thing that a right triangle can't be is equilateral, because by definition that hypotenuse has to be longer than either of the other two sides. Does that make sense? Okay. Okay. Now we're going to talk about, for what we're going to need to be able to do with triangles, is that we're going to need to be able to find the area of different types of triangles. And hopefully we already know what our area formula for a triangle is. right? What's our area formula for a triangle? Base times height divided by 2, or what else? How else could we change that formula if we wanted to solve it a different way? Yeah, 1/2 the base times height. 1/2 the base times height is what books tend to use, although I like base times height divided by 2. All right, so a vertex of a triangle is one of the points where two sides of the triangle intersect. Okay, it's basically just a point on the triangle. All right, a base of a triangle can be any one of the triangle's sides. It doesn't have to be the bottom horizontal line. Okay, we can move it around, we can orient it differently. Okay, we can do a lot of different things. The base doesn't have to be just one particular side, although it's handy if we put the base at the bottom and we're consistent. All right, the height of a triangle is the perpendicular segment from a vertex to the line containing the opposite side. The length of that segment is also called the height. So, for instance, if I wanted to find the height of this triangle right here, okay, this line is not the height of it. Okay, this line is, because it is the perpendicular line from this vertex to that line. So that's my height. That's the distance that I need to find in order to incorporate it into my formula for base times height divided by 2. Okay? All right, here in a right triangle, it's really easy because that's already a perpendicular line to my base. Okay? Over here, the perpendicular line shows up inside. So sometimes our height is inside the triangle, sometimes it's on the triangle, sometimes it's outside the triangle, and you need to be aware of that. Okay? All right, let's scroll down here. All right, the base is extended, so a perpendicular segment can be drawn to show the height. To find the area of a triangle, both the base and the height have to be known. We know that. We know our formulas. Those formulas are given here. Okay, so this is just an introduction to triangles. That's it. That's all that's in that. All right, so what we can do from here, which I guess we can't do it from there. I don't know why I didn't pull it up, but let's go ahead and pull it up. Let's look at a couple questions. All right. Let's classify this by its sides and its angles. Katie, how would you classify that triangle by its sides? It's got 3 equal sides. What's our term for 3 equal sides? Equilaterals, correct. All right. But notice that we have 2 equilateral options with B and D. Jose, is that triangle acute or obtuse? Acute. Very good. All right, so we're cooking with gas. We'll move right along. All right, Chandler, how would you classify that triangle by its sides? It's an isosceles triangle. Marcos, how would you classify that triangle by its angles? Okay, it's got a right angle, so it should be isosceles right. Okay, so we get A for that. Okay. Let's see, Jordan, how would you classify that triangle by its sides? Classify the triangle by its sides. Yeah. Scalene, good. What else? Scalene obtuse, good. All right, keep moving. All right, here we want to find the area of this triangle. So what numbers am I going to use, Michael? This one's pretty easy. They give you all your information. Okay. And this maybe this is a different document than what I sent out to you guys. I'm not sure. Oh, okay. All right, so we'll just look at this one then. So my base is 7, my height is 10. 7 times 10 is 70. 70 divided by 2 should be 35 square units, right? All this seemed pretty easy. Yep. Okay. All right, they don't even draw us a picture here, but do I need a picture if I understand the formula? No, not unless they start giving me parts that I need to use to find parts that I need. All right, in this case, they tell me that the base is 4, they tell me that the height is 12. What are we going to do with 4 and 12? Okay, Katie, what's 4 times 12? We ought to be able to do 48. 48. What's 48 divided by 2? 24. So 24 feet squared. Okay? All right. Then you get into something like this. We're going to skip question 6. That's one that could take all day and really doesn't pertain to this lesson at large. So, okay, because we start talking about perimeters. Right, an isosceles triangle. Isosceles triangle has a perimeter of 50 inches. The congruent sides measure 2x plus 3. The length of the third side is 4x centimeters. What is the value of x? Here you have to start off by drawing a triangle. Okay? All right, what do we know about the triangle? 50. What else do we know about this triangle? No, they are not. 2 sides. How do you know only 2 sides are congruent? Because it's isosceles. So let's do that there. All right, the congruent sides, right? Those 2 places with the tick marks. What am I going to write next to those sides? Jose? So I got 2x plus 3, 2x plus 3. What's the third side? 4x. All right, if I want to solve for x, I know the perimeter is 50. What should I do? What do you think, Jordan? Yeah. How? A formula? Okay. All right. What can you tell me what perimeter is? What is perimeter? The distance around a polygon. All right. So if I know the bottom is 4x, I know the left is 2x plus 3, the right side is 2x plus 3, and the whole thing adds up to 50. What kind of formula could I write? Don't make this harder. Go ahead. 50, you said 50 equals? Okay. Very good. All right, just add up the 3 sides, set them equal to the whole, right? What's the next thing I ought to do, Katie? Okay, so what are we saying when we're doing that? And you're doing the right thing, but what do we typically call it so we can shorten that phrase down? Is that combine like terms? So 2x plus 4x is 6x, 6x plus 2x is 8x. All right, what's next? Plus 6, because we're going to combine my 3's. All right, now what? Subtract 6. Okay, 50 minus 6, 44. 44 equals 8x. Divide by 8. What does x equal? What's that? 5.5. Okay? Let's see. Oh well. All right. I'm going to scroll down here real quick. We'll check our answer. Number 7. 5.5. All right. How do we feel about this? Feel like we've got a handle on it? That took a few more steps. That wasn't just classify, right? We needed to know, right? They told me what type of triangle I was working with. I needed to be able to draw it. I needed to be able to label it. I needed to be able to remember what perimeter was and how to solve it, plug everything in. use combining like terms, simplify, right? Get down to an answer, right? Do you guys think you guys can get it from here? All right. I'll stop there and I'll help with whatever you need help with.